Hello and welcome back. Today we're going to be talking about Azure Storage Account, or as we simply say, storage. Azure Storage Account typically contains majority of our Azure Storage data objects such as the blobs, files, queues, and tables. These storage accounts provide a unique namespace for your Azure storage data, which is in turn accessible from literally anywhere around the world, especially via HTTP or HTTPS web access. This means that data in your storage account becomes very durable and highly available, secure, as well as massively scalable. There are different types of storage accounts within the Azure storage account, which we've mentioned just about a minute ago. The four main types of storage accounts are our blobs or containers, our files, queues, and tables. There's also another key aspect of the storage that focuses on big data. With big data in Azure storage, the key focus is on what we call data lake storage, which is defined as a set of capabilities that is dedicated to what we call big data analytics, which is built on Azure Blob Storage. We also will discuss within this section about the different redundancy availability zones for storage accounts, such as the ZRS, GZRS, and the RAGZRS. With that, let us jump into getting more details about what Azure Storage Account does, how we can implement it, and some of the key features and highlights when working with our Azure storage. Over here, we're going to talk about the types of storage redundancy. Now we have about 5 types of storage redundancy over here. The first one we're going to start with is the locally redundant storage, which is also abbreviated as LRS. With this type of storage, we have the ability to store our Azure storage accounts by having 3 copies of storage data within one availability zone of one single region. And if you remember, when we're talking about availability zones, while talking about virtual machines, we talked about different data centers or one or more data centers being in each zone and one or more zones being in each region. And so in the case of the local redundant storage, it gives us the ability to have 3 copies of our Azure storage account data within one region, and within that one region, it puts it in just one availability zone. However, in this case, since this is the most basic and entry-level redundancy availability, if our availability goes down in this scenario, we get to lose all our storage data. The second, called the zone redundant storage, allows us to store a copy of our data in each availability zones within a region. So if, for example, in a case where we have about 3 zones within a region, the zone redundant storage gives us the ability to have each copy of our data within all those regions. As such, it is a much more redundant option than the locally redundant storage over here. The third one is the geo-redundant storage, abbreviated as GRS. This allows us to store 3 copies of our data in one single availability zones, however, between 2 different regions. And so this is a more better option than the zone redundant, because the zone redundant forces us to put our data within just one region. However, in the geo-redundant, we are presented with 2 different regions to replicate our data. One being a primary region and the second regarded as a secondary region. When it comes to this geo-zone redundant storage option, we have our data being stored as one single copy in each availability zone of our home region. We then have the opportunity to store 3 other copies of our data within an availability zone of another region. So this is very similar to the geo-redundant storage, which stores 3 copies of data in one availability zone. However, in this case over here, we have more opportunity because we get to store one single copy of the storage data in multiple availability zones in the home region, and then saves even up to 3 copies in the secondary region. And then lastly, we have our read access geo zone redundancy storage, which is very similar to the geo zone redundant storage. However, it provides us with a read-only access version of our data when it comes to the secondary region that was described for the geo-redundant storage. Next, we are going to discuss about containers. This is classified as one of the key 4 storage account types related to blobs. The container itself enables us to be able to easily organize sets of blobs that are similar to folder or directory structures within a file system in our Azure storage accounts. This enables us to have multiple number of containers within our Azure storage, and a container can then store unlimited number of blobs. So this gives us a very relative connection between our container and blobs, where we create containers and we can as well create number of containers, and then we can have unlimited amount of blobs within these containers. As we will see later on within this exercise, we do have different types of blobs that we can create within these containers. Some key things to note about containers is that they must have a valid DNS name. That DNS name itself becomes part of a unique URI, which is defined as a Uniform Resource Identifier. This enables our containers to be addressed as a link to connect to that container or the blobs within the container. A few rules applied when naming our containers, such as the containers requiring to be between 3 and 36 characters long. The containers must start with letters or numbers. They must be lowercase letters, numbers, or having the dash character. The example given below over here gives us a sample idea of what a accessed link to our blob storage account would look like. From the HTTPS down to the Windows.NET describes the entry point into our container or blob storage account. Hence, the blob is described over here. The /mycontainer is targeting a specific container within the blob storage account. And in this case, the container is called my container.